for the CABE CPD this afternoon for tomorrow's installation solutions for Future Homes and Building Standard. And Jason Doherty has kindly agreed to present the CPD for us. And he's from a company called ACTIS. And he will take it on from now. Thank you very much, Jason.
Thank you, Rosemary. Thank you very much. Thanks for the invite this afternoon. It's much appreciated. As you can see here, my name's Jason Doherty. I'm the Regional Specification Manager for ACTIS Installation. I cover all of the South East area, including London. So I go all the way virtually down to Dorset up to pretty much Peterborough way, Northamptonshire. So that's my area, but we do have other specification managers around the country. So if you don't fall within my sort of area, please do feel free to drop me a line and I can put you in contact with a member of my colleagues who can obviously cover your queries and specifications, etc. If you don't know much about ACTIS, we're a multi-fall insulation manufacturer and we've been innovating new insulation solutions for over 40 years now. Now, multi-falls are quite massive in Europe. So it's the UK market is finally getting with the program, so to speak. We are a French-based company, so our current production sites, which we have 4, are in the south of France. We are currently building a new production site as well as we speak. And hopefully the aim is by the end of 2025 that all of our production sites will be using totally renewable energy resources such as biomass and solar to produce our products. So if you've got any customers that have green credentials, etc., we have some really favourable data on this. We actually have 0 water production processes, and all of our productions are all of our products are 100% recyclable, and that's at the end of the building life or during production also. So if we have any offcuts, etc., of some of our products, we can chop it all back up and put it through the manufacturing process. We're really proud to announce that we've just received cradle to cradle certified products of our honeycomb insulation material, which I'll cover a bit later in the presentation. We are the actual market leader for reflective multi-fall insulation within the UK market. And we've sold over 25 million square meters of our products alone. And this gives us over 65% market share. And this has actually grown this year as well. On top of that, we've reinvested into development of new products and materials with our research and development department, over 65 million euros. We do work in tandem and work very closely with a lot of the industry's main bodies and boards, and we work very, very closely with the Structural Timber Association because most of our materials are for timber frame of some description. We do try and give a full cradle to grave experience when you are specifying ACTIS, so we offer on-site guidance and support as well, and we have many tools on our website. If you haven't been onto our website, it might be worth just having a look. We've also got our own YouTube channel where we present all of our installation videos. You just Google ACTIS installation and all of our videos will pop up on there. We also have a simulator tool on our website as well, where you can get an idea of how much material you'll need to gain the U values that you require. All of our production processes are ISO accredited as well, so they're tested very rigorously. So we obviously making sure that the products do what they say they should do. We offer a full tried and tested system from external to internal within a building's thermal envelope. So again, fully tested and accredited systems. We obviously have independent accreditation and there's no issues with certification within the UK market. With regards to distribution, we do not sell our products to the end users directly. So all of our products are sold via all of the builders merchants nationally and other distribution networks within the UK. And we're currently on a 2-week lead time, so there's no issues with actual materials on the ground. So that's a little bit about ACTIS. So moving into the main body of the presentation today with regards to future homes and building standards. Well, obviously the goal is to be building to net zero by 2050, which is going to be extremely hard to achieve if we continue to build in our previous building practices. So some of the objectives, what we need to do now is future-proof new homes to an extremely high standard. So this not only means increasing the levels of insulation materials, but we need to think about the whole thermal envelope. So we need to think about thermal bridging, especially at junctions of dwellings, and obviously looking at air tightness of dwellings as well comes as a very important factor. With regards to retrofit existing new homes, we needed to do this to an extremely good standard. Now, you may have heard of the Zero Carbon Trust that done many reports on looking at a performance gap, especially with regards to retrofit. And they found that in many occasions that up to 80% of the expected U values that was designed in a studio on CAD, etc., to what was actually found in real life scenario. And this is a massive, massive issue for the industry as a whole. And we've been talking about this for many years. Obviously, we need to reduce our carbon emissions and then phase out fossil fuels and then decarbonise electricity grid. If we continue to build with weak fabric solutions, our current capacity to obviously provide electricity and a grid, etc., would not be able to support the current building we have going on within the UK. Some other things we now need to take into consideration are things like electric vehicles, especially with regards to new build or change of use, etc. Some of the strategies on how we'll achieve this. So obviously there's been an uplift to new requirements to achieve nearly zero energy buildings. We'll be looking at some of the Part L changes with regards to energy efficiency. We'll have a look at the ways we can address the performance gap with tried and tested systems. We'll be touching on some of the issues and new developments within SAP 10 and looking at some solutions on how we can meet these new targets. So some of these new targets you may have seen on your SAP results. So there's a new primary energy target for all buildings. There's a target CO2 emission rate for all buildings, also known as TER. There's also a target fabric efficiency energy rate for all dwellings, or TFEE. However, if we're going to be insulating greater, making buildings much more airtight, etc., there are some unintended consequences. So we'll be touching on new approved document O with regards to overheating, looking at Part F with regards to ventilation, health and indoor air quality. Some of the products that we specify can really affect this, and the VOCs they emit, etc., are vitally important. All ACTIS products are A+ rated, so very, very low emissions. We'll also be looking at some ways we can improve compliance and some of the calculations and evidence that are now required in the industry. So as we know, from last June, there was a 31% uplift over current Part L regulations. Now, when thinking about a new build, we need to think about this as a recipe. So we can work to two different kinds of figures. So if we work to limiting figures, this would be in a cake world or a recipe world, a bog standard cupcake. So this is the absolute minimum that the construction specifications must achieve. However, we can then work towards more notional figures, which is a model specification based on a recipe that sets the energy efficiency targets for that dwelling. So in a cupcake world, we could add sprinkles of chocolate icing. Now, this is a basic SAP calculation and how we view a typical heat loss or thermal loss from a typical dwelling. So 85% of the thermal energy is expected to be lost via the building's fabric, be it the roof, the walls, or the floor, which is massive. And then on top of that, the additional loss from that dwelling would be via ventilation. So this could be poor fitment of insulation materials at the building's fabric, or it could be a ventilation strategy. Now, within this recipe, we would then take into consideration the external gains of the building. So how much glazing the building has, where it's situated in the country, if it's south facing, so on and so forth. Then we'll take into consideration the internal gains of that dwelling. So the amount of people expected to occupy the dwelling and the kind of lighting and heating systems the dwelling is expected to be using. So you may have heard this phrase, so we need to build tight, ventilate right, and bridge the performance gap with a fabric first approach. So what do we mean by fabric? Well, there's usually three elements we take into consideration. The first element that I'm usually asked for is the U value of an individual element of the dwelling. Then the second and third thing we need to take into consideration, as I previously mentioned, are the thermal bridging and the air tightness of the element. So here you can see a typical dwelling with a strong fabric solution, and it's retaining the most of its thermal energy, and it's emitting less CO2 emissions. It's also impacted less greatly by external factors. Therefore, we could apply less renewable energy generation, saving money, and it would cost a lot less to run this type of dwelling. And looking at the energy bills we're currently facing today, this is vitally important. If we continue to work with weak fabric solutions on dwellings, again, the exact opposite, increased in CO2 emission, increased thermal loss, and then would have to offset that by more renewable energy generation, and it would cost a lot more to run this type of dwelling. So U values are vitally important, as we all know. So this is one of our typical U values for a timber frame wall. This is using our three-part system, using our insulated breather membrane on the outside in the cavity there, and then we use our honeycomb insulation in between this stud, and then we use our insulated VCL on the internal face. And this gains us a very favourable U value of 0.14. Now, obviously, U values is the thermal transmittance value of a specific thermal element, always expressed from going from warm to cold. And these are expressed in the value of watts per metre squared Kelvin. Now, we have to follow specific conventions, etc., and protocols when running U value calculations. And some of these conventions have now been tweaked and updated in line with the new Part L regulations, and one of the main ones being BR 443. Also, it's vitally important we think about condensation, because we can sometimes be doing more harm than good. Now, all of our calculations come with a condensation risk analysis and a dew point calculation. And we run our condensation risk in line with BS 5250 and the Glaser method. Now, you may have come across these before, but it's always good to recap. These are under the new Part L regulations. So new build is split into notional and limiting, as I mentioned earlier. So walls need to achieve anything between 0.18 to 0.26. Roofs are anything between 0.11 and 0.16. And floors are anything between 0.13 and 0.18. Existing, however, is split into two. So the first section is new replaced, including extensions. So walls must achieve 0.18. Roofs must now achieve 0.15 and floors must now achieve 0.18. Renovation, upgrade and retained, we've got slightly more wiggle room, so to speak. So walls must achieve still 0.30. Generally, I'm asked for a 0.28 in that scenario. Roofs are now must achieve 0.16 and floors must achieve 0.25. Now, the new conventions obviously do clarify on how we now need to run calculations. Now, if you've not specified multiple insulation materials before, they do react slightly differently to traditional insulation. So here you can see one of our typical solutions for a roof, and you'll see the insulated breather membrane on top of the rafter. Now, this membrane is actually 35 mil thick here, as you can see. But when compressed between the batten and the top of the rafter, the actual multifoil will actually puff and pillow. So this convention is known as a 70-30 split. So 7 mil of this 35 mil will puff up into the counter batten zone. 7mm will compress, and 21mm will drape. Now, we have to take this into consideration when we're looking at the core R value of the product and its associated air cavities. Now, these layers are inserted within the U value calculation as separate layers alongside the other layers of the build-up. With our insulated vapor control layer, the foil at the bottom of this drawing, the total thickness total of this product is 45mm thick. Again, when compressed, 9mm will puff up into the rafter zone itself, 9mm will compress, and 27mm will drape. So we need to ensure we're taking this into account. If we don't, this will then add to the performance gap because the resistances of the air cavities would be incorrect. Now, within a wall scenario, multifoils react slightly differently to under direct gravity. So it's a 50-50 split. So if we took our insulated vapor control insulation layer, for instance, 18mm of that insulation would puff into the stud, 9mm will still compress, but 18mm will puff outwards. Like traditional insulation materials, we don't generally fulfill our actual elements with our products because the low resistance or low emissivity cavities can enhance our products for free. So looking how this is clarified within a U value calculation. So this is our insulated vapor control layer. So layer 7 is obviously the puff up of the material, 9mm, and you also notice it is also bridged by the element it's puffing up into. So this is the rafter zone at 600 centers. Then you'll see the compressed layer, layer 8, and then the layer that drapes, layer 9. So it's 27mm, and that's draping into the counterbattens before plasterboard. So it's vitally important then when running calculations that the person is competent and understand how the products work. Obviously, ACTIS can offer that service for free. Now moving on to air tightness. Now this is obviously the measure of air leakage of a building through the gaps, cracks and holes in the building's fabric. One of the main changes that air tightness is tested is required on all dwellings, including large developments. So testing of house types only is no longer allowed, and that is a major change for large developers. You may have all come across the blower door test, which is the test kit on the left-hand side here. But there's also a new bit of kit which you may come across, which can be used in conjunction with the traditional blower door test, and that is pulse methodology. Some of the other changes with regards to air tightness, limiting air tightness levels are lowering from the current 10 down to 8, and this coincides with building tighter. However, the notional air tightness is now set at 5. Now, air tightness is linked closely with a ventilation strategy, and this is where we need to take into consideration part F. So if we build tighter than the level of 3, we may need to introduce mechanical ventilation. So then I've found this already within cityscapes where we haven't got a natural ventilation strategy. Now, with regards to thermal bridging, multifoil insulation materials have some major advantages with regards to thermal bridging, especially at junctions of buildings, because they're extremely flexible and provide a continuous insulation, be it on the outside or on the inside. So a thermal bridge is where a penetration through the insulation layer occurs and then heat is transferred through a non-insulating material, such as timber. And this generally happens at construction details. So the products that we're specifying, the manufacturers should be able to provide you with construction details to ensure this doesn't happen. Now, this linear thermal bridging is defined as a linear thermal bridge, especially at junctions. Now, the second drawing or photo here, you can see a typical wall solution with insulation in between studs, and you can see the amount of thermal leakage through that without a continuous insulation material. Now, this heat loss at linear thermal bridge is quantified as psi values. Now, all these psi values in our recipe, going back to our recipe, together divided by the sum of exposed elements in a SAT calculation, make up the overall heat loss of the building through linear thermal bridging. Here you can see two independent thermal imageries of our products being used. So it's a two-part product, our honeycomb product and our insulated vapor control. And you can see it eliminates all thermal bridging, especially at the junction where the two walls meet. So until now, heat losses owing to junctions in the construction have been offset by the ACD scheme or accredited construction details. However, these ACDs have been considered to be inaccurate and not fit for purpose based on current building practices. So they've actually been removed and can no longer be used. However, psi values can be used if modelled by a competent person. ACTIS can provide this service for you. We do have software to provide most junctions of dwellings. However, some junctions we cannot perform, but we do work closely with an independent agency. There are also non-government body databases that you can take this information from. So if the SAP assessor isn't aware of how a junction is going to perform, they would have to apply a default figure to this. Now, if many default figures were used in this actual recipe, so to speak, or calculation, then it will be extremely hard to pass your SAP fabric within the new SAP 10 world. You could apply notional values within the recipe, or you could come to someone like us where we could provide you with our model junctions, and you can see there's a vast improvement. So table K1 values or default psi values can be mixed with known values. If this is not possible, then the overall default Y of 0.20 must be applied. However, this default has been worsened quite dramatically from the previous default of 0.15. Notional values sit at 0.05, but reflective insulation can actually achieve as low as 0.03. So again, major advantages. Now, fabric first approach. Now, it's all well manufacturers test in blue sky laboratory conditions, but it's vitally important that the products that we specify actually do work in real life scenario. So we've actually had some independent tests done using our products and solutions. So the first test I'm showing you here was done by the Glasgow Caledonian University. Now this was a wall setup, and in the laboratory conditions, this wall was expected to achieve a U value of 0.28. After testing, this wall setup was actually achieving on average a U value of 0.22. So we're really confident that the products do what they say they do. We've also had some independent blower door test results, and this one was actually prior to installation of the plasterboard. Now, passive house usually comes out around 0.6. This air tightness test actually received a value of 0.78. And again, back to our independent thermal imagery, again, two-part system doing what it says it does. Now moving on to on-site evidence. Now you are probably aware there's much more evidence we now need to provide, and some of it is to be provided at design and as-built stage. One of these reports is a new BREL, and we obviously need the addition of geotagged photographic evidence of build quality. Obviously, we need to focus on the continuity of insulation, especially at junctions, so construction details should be available for all the junctions within the dwelling. On-site audits would obviously continue to be carried out, and this is generally before elements are concealed, and again, photographs of these are to be taken as per the guidance list. All of this evidence and reports alongside the EPC are then provided to the client, building control, and more importantly, signed off by the developer. Another thing which has been introduced is a new home user guide. We're introducing many new different technologies into our new dwellings, and many people may not have used these. So this guide is going to be vitally important on showing them how to use their new types of systems. especially like ventilation, hot water, etc. And obviously ways to avoid overheating. So construction details are vitally important. If they would assist you, please do drop me an email and I can provide these for you. So these only assure as-built energy performance, but they also provide products developed to fit a specific system. They also give additional detail on site. Products that we specify should be easy to install and not so reliant on specialists. How many times have we gone to site and seen rigid materials stuck in with filler foam, etc.? We need to focus on continuous insulation and airtight layers, and multi-foils have a massive advantage with this. Again, with regards to condensation, should be providing integrated service voids, and these should remain undisturbed by follow-up trades. Again, I've had issues in the past where we've had VCLs installed, sealed tight, etc., and installed correctly, and then a follow-up trade has put a cable or pipe through it and not sealed it and caused condensation. The manufacturer should be able to offer guidance, be it on site and training. We go around the country training on site. Many people that haven't used this before will go and give them guidance and support. We'll also work with a lot of modular timber framers. So we go to their factories and show them how to install our products correctly in a factory setting. But if that would be assistance for yourselves, please do give us a shout and we'll be able to support you with that. Now looking at new approved document O in regards to overheating, and this is applicable to new dwellings only. And this looks at the need to limit unwanted solar gains, especially in summer, and provide adequate means of removing excess heat from indoors. Now, generally, we can do this via passive means, especially in countryside and suburbia. However, this may not also be viable within a cityscape scenario. We would generally try and do this via openings, shading, and a ventilation strategy. However, if this can't be met, we may need to introduce air conditioning. Now, some of the way we need to show compliance with approved document O. So there's currently a couple of test methods that we now need to follow. So there is a simplified test method, which I can assure you isn't simple. And this shows that dwelling must be below maximum glazing area percentage threshold, above minimum 3 areas of individual openings, etc. And then we apply added shading if required. But this is very much dependent on location and cross ventilation possibilities. Then there's another type of testing called dynamic modelling, and this is usually used in cityscape, and this is using a software to demonstrate pass. Now, this kind of modelling is based on much more data, and this includes top weather data, occupancy, and some of the things I mentioned, like internal gains, so on and so forth. Now, these checklists and compliance must be demonstrated by a competent person. And if the dynamic modelling report shows a pass, this must be provided to building control. Just to note, the simplified method is not suitable for buildings with more than one residential unit, which use a communal heating or hot water system. Now, more data is required when this modelling occurs, and this modelling includes the calculation of thermal mass, which is the capacity of the construction to absorb, store, and release heat. This is also influenced by phase change of build-ups. So we then need to calculate the capacity of the materials in the actual construction and their ability to store and release heat at a later time. The more time delay, the better. So to calculate thermal mass, kappa values are required, and ACTIS can provide these, and these usually come along with your U-value calculation. Now, kappa values are calculated using the density and heat capacity of the individual components in the build-up of the element concerned. So, for instance, if we had a wall with a block, for instance, and we specified a specific block within this calculation, and it also has a specific density and heat capacity, and then the end user went and changed it for a different type of block, this would alter the kappa value. So again, we must stick to the specification. Now, some of the changes within SAP 10. So as we all know, we are trying to abolish gas for heating new homes by 2025, which is going to be quite a challenge. So this is pushing the priority of reducing carbon footprint and then incorporating renewable energies. So to reflect this, many of the fuel types recognised in SAP have had their fuel prices, CO2 and primary manufacturers changed, the most significant being electricity related carbon emissions. This just reflects the increased influence of renewable energy technologies that's producing electricity for the national grid. Some of the main changes to take away from SAP: default values are lowered, so it's going to make it extremely hard to pass SAP without the correct model junctions. ACDs are no more, so use the types of site like the LABC construction detail site. It's now more vitally important that we take into consideration the whole building's thermal bridging and then applying appropriate building technologies to minimise carbon footprint. However, to achieve our goal of net zero by 2050, we all need to work together objectively and have a collective strategy for meeting all these new targets. So Part L, 31% uplift on U values for all dwellings. We must adopt a fabric first approach. We need to obviously reduce the impact of linear thermal bridging, especially at junctions, so construction details are vitally important, and then improve air tightness with continuous insulation at these junctions. However, we then need to address things like overheating and ventilation strategies, etc., and air quality. Model junctions are extremely important, so if these would help you, please do come and knock on our door. We might be able to assist. And then applying the efficient building technologies. We certainly do need to bridge the performance gaps from what is designed to what is actually built in real life. So again, manufacturer support and guidance on the installation of materials is vitally important. And we now need to prove compliance. There's a lot more proof, etc., that we now need to supply. I now believe this is making the industry more responsible and transparent. However, these are just some of the stepping stones towards future homes and building standards. So there's much more to come. Now moving into our product range, if you're not aware of it. So we've got 4 products in this range, and it's called the hybrid range. So we have our honeycomb insulation, which is a great alternative to traditional insulation materials. And this is inserted between rafter, stud, joist, or anywhere it can be suspended. And then we have our multifoils. So we have a multifoil with a vapor control layer function, which is always installed on the warm side of construction. And then we have insulated breather membranes, which go externally. So the silver one here is the one for walls. And then we have a black one, which is the one which is applied to the top of roofs. All of these products are independently tested, laboratory tested, and in situ verified. We offer a full system solution from external to internal, as I previously mentioned. However, we can mix and match our insulation solutions with traditional insulation. So as long as one of our products is in the specification, we're happy to provide you with a U value calculation. So this is our honeycomb product. And as I say, it's called Hybris, and it's just received cradle to cradle certification. Now, this is a friction fit product. So we overcut this product 5 to 10 mil. So when we measure our centers, we then mark our bale. Now, if you've got 400 centers, you'll be cutting this bale approximately into 3. And if you've got 600 centers, you'll be cutting it approximately in half. The beauty of this product is you get no dust, mess or fibre of this product whatsoever. So it's a lot more cleaner for the user to use. And it can make it a lot quicker because you can get up to 4 panels with one cut. So again, reducing labour costs, etc. When you've cut through your panel, you can then take off the outer wrapper, and it comes in a concertina like this. Now, once you've got this concertina, you then extend it, and it extends to approximately 1.2 metre in length. Once you've extended it, you'll notice all of the cells, or simplexes as we call them, open up. We then flip it over and extend it again. You will notice one side of all of our products has a coppery coloured side, and one side has a silver coloured side. This not only helps the installer ensuring it goes in the correct way round, but the copper coloured side is a slightly thicker vapour control layer. Now this product comes from 50mm thick up to 185mm thick. 125mm of this is approximately equivalent to 100mm worth of rigid board material, and this is with associated air cavities. So within a wall, we like to have a low E cavity at the front or warm side of this product. Within a roof, we like to have a low E cavity top and bottom, a minimum of 13mm roughly, 1-3. Then moving on to our insulated vapour control layer. This obviously goes warm side of construction. So this is stapled directly to the front of the stud, rafter or joist. And as with all VCLs, it must be foil taped to ensure air tightness. We generally recommend 100mm foil tape. Then to provide an integrated service void, and obviously to allow the puffing and pillowing I mentioned, we generally use a 38mm counter batten before applying plasterboards. Now multifoils can be a little tricky to cut, so we do recommend a cutter that we've developed which compresses all of the layers of this material together, and it has a blade which just glides through, which is specifically helpful especially at junctions of the dwelling. This product is equivalent to approximately 40mm worth of rigid board with 2 associated air cavities. This is our insulated breather membrane called Boost R Hybrid. Now this is a reflective breather membrane with additional added insulation material, and it's stapled directly to the outside of a timber frame wall, be it the OSB or ply. We must overlap this product to ensure water tightness, and then apply a specific foil tape which we supply called multi-adhesive tape, which is a lot stickier. Once it's taped and sealed, again using the cutter just to cut around your junctions, we then apply the appropriate battens before your cladding system goes on. We can use this within a brick clad cavity, but we do need to ensure within that cavity zone, we now need to allow the thickness of the product, which is 35mm thick, along with a clear 50mm cavity to ensure we're complying. So in addition, basically what I'm saying is we need an 85mm cavity in total. This product is equivalent to having around 30mm worth of rigid board on the outside of your dwelling. Now moving to the roof insulated breather membrane. This is directly attached to the top of your rafters. Again, this product is 35mm thick, but in addition, this product has a built-in lap and tape. This just ensures the continuity of the height of the actual membrane itself. Because of the puffing and pillowing, we do normally recommend a counter batten before applying tile battens. This just allows a clear passage for any water to disperse on top from the top of the membrane down the roof. If this cannot be done with a counter batten, if you've got a semi-detached house or terrace housing, we can offer a draped solution using this product, but this is very reliant on the installer to drape sufficiently below the actual tile battens themselves. Again, this is equivalent to having approximately 30mm worth of rigid board above your roof. I just wanted to touch on part B because it's obviously vitally important. Now, most reflective insulation products are usually combustible, be it rigid or multifoil. However, internal fire resistance is achieved as a system with a non-combustible lining board, such as plasterboard. Compartmentation is achieved through the provision of fire stops, and the use of appropriate cavity barriers at relevant locations are vitally important. We allow for an appropriate safety cavity in the vicinity to heat sources such as flues, etc. And we do not carry insulation of this type over compartment zones. Again, we cannot use these kinds of materials on and throughout the external wall of a relevant building over 18 metres in height and 11 metres in height for residential purpose group buildings. Obviously, it's vitally important we follow the approved documents, B, volumes 1 and 2, and Building Regulation 7. And we always follow the STA guidance for fire safety, specifically during construction of timber frame, and then follow the specific site requirements. On the back of this, obviously, we've done many fire tests, etc. If you'd be interested in our fire certification and test results, please then do drop me a line. I'll be happy to provide this for you. We've done all of our testing in association with Warrington Fire that I'm sure you've all aware of and heard of. So obviously part B states a 30-minute fire resistance is required for domestic 2-storey buildings. Now we were advised to test this wall assembly under a load, and we tested it under a load of 75%, which is like having a small gathering on the first floor. And you may or may not know, studs will fail quicker when under a load is applied. Now this just used our honeycomb material within a 140mm stud with a standard plasterboard, etc. And pleasingly, we've got a pass result of 38 minutes. This is just a snapshot of our simulator tool, which can be found on our website. Again, this is great to be used as a guide to see how much material you require to get to obtain the U value you need. But again, please do only use it as a guide. We do have to put certain parameters within this specification tool. So again, if you do need help with U value calculations, please use either the technical team or myself directly. Now, these are just some of the solutions. I'm not going to go through them all tonight because we'll be here all evening, but some of the typical solutions we do specify. To hit 0.16, which is generally an upgrade, we can get a 2-part system to work with our 125mm honeycomb and our internal multifoil. To hit more of a notional figure, when we're looking at new builds, traditionally I'm now finding most new build structures, a rafter minimum is usually around 225 at 600 centres, but our 3-part system can get you a notional figure in a 250 rafter at 600 centres using both multifoils and our 185mm honeycomb. Walls are a lot easier to obtain the current U value targets. So our general solution for most modular timber framers is the top one. Within a 140mm stud, we can use our 105mm honeycomb with our internal multifoil with a standard reflective breather membrane. To obtain 0.18, we can use a 2-part system with our 105mm honeycomb and our internal multifoil. If we're just looking at upgrading, we can actually get down to an 89mm stud using our insulated breather membrane with our 50mm honeycomb system. Just a note, new conservatories without thermal separation are now to be treated as new thermal elements, as I'm sure you're aware. Now looking at solid wall solutions. Now these can be a bit trickier. So anything generally as a rule of thumb pre-1920, these walls are designed to breathe. So generally there's only 2 ways we can tackle this. So the first way would be normally a vapor open solution, such as a sheep's wool or a wool, etc. Or alternatively, if we can ventilate a cavity, a minimum of 25mm, between the timber studs and our vapor close solution, then we can potentially offer a solution. But any newer solid wall, we can offer a solution. So to obtain a 0.28, an upgrade in a non-absorbent wall, our 105mm honeycomb can get us there. Pitched roofs, we're finding it more difficult to obtain the new regulations, so 0.16 and 0.15. Generally, we were finding that these rafters are usually set at 100mm at 400 centres, and usually with a sarking felt. Now, we have introduced a new product called a OLIS to the market in that scenario, where we've done a more scientific study with regards to condensation risk analysis. If you need more detail on that, you'll find that on our website. It's called AOLIS HC. But these are some of the current solutions we can offer with our hybrid range. So 0.16, 140 honeycomb with our internal vapor control layer. Or 0.15, we could do 155mm honeycomb with our 200mm rafter. Obviously, we would have more solutions with our 3-part systems within a smaller rafter depth, so if the roof covering's coming off. We also do a lot of suspended timber floor upgrades as well, and this is just using our insulated breather membrane below joists, and this could obtain us a U value of 0.23, where the current target is being 0.25. So it's a clean, quick solution for you. Now, just moving into case studies. Now, this is a new build, one of our clients, and this has achieved some good U values. So in the roof, we achieved a 0.14, and they generally use a 2-part system. So in a 225mm rafter at 600 centres, they use our honeycomb insulation and then our insulated vapor control layer. And then in the walls, they use 3-part system that I mentioned previously, the insulated vapor control layer with our honeycomb insulation in between a 140 stud and a standard reflective insulation breather membrane. On the back of that, we do many, obviously, renovations and conversions, etc. And we've been on George Clark's quite a lot recently. You may or may not have seen this, but this is one of our clients who achieved 0.19 in his roof and 0.16 in his walls. And as he'd done most of the work himself, he wanted it to be quick, clean, and easy to install. He didn't have to wear any mask or PPE, as there was no dust, and it was easy to cut and fit. Plus, it worked out a lot cheaper than the alternatives. So just to recap and conclude on what are the benefits of multi-foil insulation. They provide a continuous insulation over the whole building envelope. They vastly improve air tightness and moisture control. They significantly reduce thermal bridging, especially at the junctions of the dwelling. And they are thin insulation solutions. Believe me, they're much more flexible and forgiving to use and not so reliant on specialist workmanship. And they can obviously then provide maximum site or SAP improvement, so maximising site potential and potentially reducing renewable energy costs on that site. That's all of the slides for this afternoon. Hopefully you found that of some use.
That's great. Thank you very much, Jason. Let's see if there's any questions in the chat. Bear with me. Somebody asking if it's possible to get a copy of the slides.
Certainly, I'll send them to you, Rosemary, and you can distribute them.
Thank you. And then someone asking, Tim is asking if there's any issues between fire stopping and the thermal bridging of your products.
Well, when we're working out, so the fire stops are generally away from the actual insulation materials themselves, but when we're running thermal modelling, we do take fire stops, etc., into consideration within that model junction. So again, depending on where they're situated within the construction, it can affect that psi value, so to speak.
Okay, lovely. And then one from Julie. How does your system compare cost-wise to using PIR insulation? Okay,
so there's many things we need to take into consideration. So cost per square metre is generally around about, dependent on thicknesses, etc., £3 to £4 a square metre cheaper. Then we take into consideration labour costs. It's dramatically reduced. And then we're not filling skips with lots and lots of off-cut material. So again, generally we find with traditional rigid board, etc., you're usually filling skips quite frequently with that kind of material. So on a typical, say, 150 square metre loft conversion, we're generally getting fed back. The contractors are saving £1,500 to £2,000 a loft conversion using our system.
Fabulous, thank you. Is there any more questions from anybody else? Oh, there's one more just come in. Is there an opportunity to improve or eliminate the fact that the material is combustible?
As I'm aware, there's not any A1 non-combustible reflective insulation materials on the market at the moment. Now, there are some insulated multifoils that have a fire rating, but they're not A1 non-combustible. So at this point in time, I would say if you wanted to increase fire rating, you could then add additional plasterboard or a non-combustible building board. What I do find, obviously, there are fire rated plasterboards, or generally, as a rule of thumb, most of the timber frame modulars use a 15mm plasterboard, or they do 2 layers if it's particularly vulnerable. If you're looking at an outside insulation solution, then and it's close to a boundary, etc., then we generally incorporate a non-combustible A1 rated fireboard on the outside of that construction. But there are ways and means around it, but you'd have to obviously add additional non-combustible boarding.
Thank you. And then just one last one I think we've got is, are they available off the shelf, or is it always on a 2-week lead time?
No, it's on the ground at the moment, dependent on sizes. All of the popular stuff is on the ground. We do have dotted about some of the larger depth sizes, but again, we can pull from different parts of the UK as well, because we use the likes of some of the main distributors such as Minster and Encon that deal with the main builders merchants around the UK. So Minster covers like the Stark Group, previously known as Saint-Gobain, like the likes of Jewson's, Gibbs and Dandy, etc. Then Encon usually do the rest, etc. So again, plenty of stock on the ground as we speak. We've had a record year and the orders continue to flow in, which is great for Actis. But yeah, generally you can just go into a merchant and they'll be able to get that under a 2-week lead time.
Brilliant. Okay, I think that's it then. Nothing else coming in. So for those that are online, I'll get those CPD certificates sorted for you. And when also Jason sends through the presentation slides, we'll send those out as well. So thank you very much indeed, Jason, for your time this afternoon.
No
there's
problem.
one last little question. Are your products going through NHBC accepts, or have they gone through?
We're NHBC accepted.
There we are.
Yeah.
That's it. Simple then.
Yeah.
Lovely.
I won't elaborate.
Just yes, it's a simple answer.
Yeah.
That's brilliant. Okay, thanks very much, Jason, indeed, and have a lovely evening, everybody.
And you, thanks for your time, everyone. Nice to meet you all.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye.